We present an approach for adding editable directed gaze animation to virtual characters animated using motion capture. Directed gaze is a coordinated movement of the eyes, head, and body toward targets in the scene. Animating gaze requires a great deal of labor and skill due to the intricate spatial and timing relationships involved. Performance capture is of limited use for gaze. Recorded eye movements tend to be noisy, high frequency, and seldom fit the virtual scene and narrative requirements. Our approach makes the animator's work easier by automatically inferring the gaze behavior that matches an input body motion and virtual scene, and by providing controls for convenient editing of the gaze behavior. In this example, we see a captured motion of a person walking around. The motion contains no eye movement, making the character appear lifeless. Our approach can automatically infer a gaze behavior that matches a scene by analyzing the body motion signal. Our analysis searches for clusters of head and torso joint acceleration maxima, which correspond to beginnings and ends of gaze shifts. Having inferred the sequence of gaze shifts that matches the body motion, we can synthesize the gaze animation and get a more lifelike and believable character behavior in a completely automatic way. For each inferred gaze shift, our approach also infers the gaze target, what the character is looking at in the scene. When determining the most probable target location of a gaze shift, we take into account head movement direction, which objects in the scene are important, and whether the character is about to touch or pick up an object. Having inferred where the character is most likely looking, we create a gaze target handle at that location. The result is a model of the gaze behavior that specifies a gaze shift sequence anchored in the scene. This model affords convenient manual editing of the gaze behavior. We provide a graphical tool that allows the animator to add and remove gaze shifts, alter the character's posture during gaze, and edit the layout of the scene and gaze targets. Our system automatically synthesizes the gaze animation that matches the new gaze shift sequence and spatial layout. To improve the expressiveness of the final motion, we can introduce probabilistically generated saccades and eye blinks in a post-process. In the remainder of the video, we show further examples of gaze animation created using our inference and editing approach.